Okay, so I'm going to solve another equation with fractions, but this time there are variables in the denominator. So we are going to do it the same way. We're going to find a common denominator and multiply the equation through by that common denominator, and that will eliminate the fractions. A common denominator ensures that all the denominators go into that evenly. So there's going to be a lot of crossing out, and you're going to end up with an equation that does not have any fractions. So if you look at this equation, we have 5 over 2x equals 17 over 18 minus 1 over 3x. So let's concentrate on the denominators first. 2x, 18, and 3x. If we look at 2 and 18 and 3, 18 goes into 18, 2 goes into 18, and 3 goes into 18 6 times, right? So 18 is going to be part of it. Since we have an x, excuse me, the x is also going to be a part of it. So 18x is going to be our common denominator. So we are going to take each term and multiply it by an 18 over x. 18x, I'm sorry, I said that wrong. Okay, so basically, if you look up here, we did this, right? And we just distributed the 18x down here. Okay, so now all the denominators should be able to be canceled out. So the x's cancel there, and 2 goes into 18 9 times. That's how I like to do it. Okay, the 18 goes into 18. There is no x there, so this will have an x in it, that 17x term. This x cancels. 3 goes into 18 6 times, so you're left with 6 times 1. Okay, so 9 times 5 is 45, equals x times 17 is the same thing as 17x. We like to write our numbers first, then our variables. Minus, keep that minus, 6 times 1 is just 6. Okay, so add a 6 to both sides. Why did I add a 6? Because I saw that the x term was on this side, and I want to isolate the x term all the time, okay? So this number, I picked the opposite of what that is and add it. And that ensures that that goes to 0. And I'm left with 17x on that side. So then I have 45 plus 6, which is 51. And then, did you know if A equals B, then B equals A? Okay, symmetry about the equals. So since this x, I want it to be on the other side, I'm just going to take what's on this side and put it, I'm just going to switch sides, and I'm allowed to do that, okay? So divide both sides by 17, and I believe 17 times 3 is going to be 3, 4, 5, yeah. Okay, so 17 goes into 51 3 times. So your x is going to be equal to 3. We didn't get 0, so this is a solution. It should be a solution. Let's check it real quick. So we have 5 over 2 times 3 equals 17 over 18 minus 1 over 3 times 3. So with x equal to 3, I should get a true statement. I should get a number equals a number, and it'd be the same number, okay? If this is truly a solution. So I have 5 over 6 equals 17 over 18 minus 1 over 9. Okay? So this 1/9, I'm going to change that to 2 over 18 because that has an 18. So then I get 5 over 6 is equal to 15 over 18. Well, 15 is 3 times 5, right? And 18 is 3 times 6. 3's cancel, so I get 5 6 equals 5 6. Okay, so it does check. So x equals 3 is your solution. Okay, that wraps that one up. Solving a rational equation with a variable in the denominator. Thank you.